So today we're going to start exploring exponential models, and what we'll be looking at specifically is looking at a germ population that doubles in size every day if left alone. What we're going to do first is we're going to take some time now. We're going to organize our data by doing a table, and we're going to label our table. And when we label our table, we want to make sure we use units properly. So we're going to put the number of days, and then we're also going to put the germs. That is to say, we'll keep track of the number of days that are elapsing and the germ population that is occurring. So at 0 days, we have 3 germs. At 1 day, we have 3 germs times 2, which gives us a germ population of 6, and that is because the population doubled. At 2 days, we're going to head and double the population from the previous day, and that is to say we will do 3 times 2, and then we're going to multiply that again times 2. Notice that 3 times 2 is really 6, which we are supposed to double, which will give us 12. When we do 3 days, we are again going to look at the previous germ population. That is to say, 3 times 2 times 2 times 2. Recognizing that 3 times 2 times 2 was the previous germ population of 12 germs. Since it doubled, we now have a population of 24 germs. At day 4, we will have 3 times 2 times 2 times 2. This will represent a population of 24 germs, which was the previous germ population, which we will then double, meaning we will multiply that by 2, which will give us a new germ population of 48 germs. What we begin to notice here is that we keep seeing a pattern where the number 2 keeps repeating. That is to say, we see the number 3 being multiplied by 2 after 1 day, the number 3 being multiplied by 2 times 2, the number 3 being multiplied 2 times 2 times 2, and the number 3 being multiplied by 2 times 2 times 2 times 2. Let us now rewrite these expressions as a simplified form of exponent notation. That is 3 times 2, 3 times 2 squared, 3 times 2 to the third power, and 3 times 2 to the fourth power. This will give us the same answer as in our table. That is to say, the exponents in this expression are also being related to the number of days in our table. Let us look now at how the exponents and the number of days are related. Day 1 is the same number that would show up where we have 2 to the first power. Day 2 is the same number that will show up in our exponent as 2 squared. Day 3 as 2 to the third power, and day 4 would show up as 2 to the fourth power. Now that we have generalized a pattern, we can find the germ population at 6 days, and that is by multiplying 3 times 2 to the 6th power, which will give us a germ population of 192. So the germ population will be 192 at 6 days.